Hello. Hello, everybody. Well, I'm Jordi Bailina from ZisK. Um, as you know, ZisK, brief introduction, probably most of you already know, but ZisK is open source, ZK AVM, RISC-V based, 64 bits, full security, quantum resistant, 128 bits. We just, during this week, we just launched 1.0 alpha. We say alpha because security, the security in the ZK, we are taking it very seriously. So we prefer to say the things as they are, and even that the high experience of the team, even that we have on the space and in the ZK, we still want to run some more internal audits, especially with the new AI tools, and also we are working formal verification to make it as safe as possible. Said that, the product is finished. Besides that, product is finished, product is ready. You can start using it. Said the chances that there are some bugs are low, but are still there, and in the coming days, weeks, even months, we are going to work hard on that. The final goal, of course, is formal verification, which will be probably the next challenge, on this. Okay. So that said, it's code freezing. Probably, things that we are a little bit waiting for what's going on is especially in the Poseidon. We switch back to Poseidon 1. But maybe at some point we switch to Blake. This is probably the biggest thing that we are still adopting, if just again for security reasons, just trying to check what's the most safe thing. Okay. So, but today my talk is, I want to talk about how we can decentralize the proving system. Okay, and before starting, I want to do some reflection. I'm sure that most of you already done. It's like in the last years, the grade of centralization that Ethereum just, Ethereum is happening. Right now, especially block builders, MEV, validators are doing every time less job, less work, and the main work is done in the builders, okay? And this is something that we have seen in the last years, but this can become even worse in the next years, especially when we introduce the ZK proof. ZK proofs are amazing because it allows you that just somebody just built a big proof. It takes it takes whatever, but then verifying is very asymmetrical. So this is very easy to verify. The problem is that generating this big proof may become a source of centralization, and especially for censorship resistant, this may become problematic, especially if. So imagine in a place where Ethereum has like 1 million transactions, and the alternative, if this centralized entity does not exist, it's only 1,000 transactions. So then you just stop Ethereum if this main source just happen. Okay, so of course this requires a lot of engineering, a lot of things at protocol level that needs to be addressed, and I'm not trying to solve like the full problem here. But I want to explain a little bit regarding the proof generation, how this can be decentralized. And actually it's relatively simple, okay? And well, here is when we are ready, for example, for building this, for proving real-time blocks in Ethereum. Right now we are not doing that in a single server. Actually, we are using a cluster of servers. We are using 16, 10, 16, around 16 GPUs, 16 servers with 1 GPU each, or sometimes some clusters of servers, okay? One server with 8 GPUs, and then we have 3 of them or 2 of them. But at the end, we already have, so all the proof generation is already built in a decentralized way. And one thing that I want to make you notice is that the quantity of interactions, we say it's a cluster, but actually it's not so the quantity of interaction, the quantity of bandwidth that you need between these servers is very, 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 very low. Actually, in ZisK, we minimize, so we took this parameter so actually we are doing some extra work in the servers in order to minimize this bandwidth, Okay? And it's not about bandwidth, it's about latency. I mean, it's about the quantity of interactions. So if we see how a normal proof works, I mean, when we have to proof a block, we get all the information, all the input of the block. Okay? This input is sent to all the workers. Okay? These workers can be servers in the same room, but it can be workers around the globe, so each one in one place. Each of the workers is, well, it's doing, there is part of the computation that's executing the block and doing some, what we call the executor, that this is done in all the servers, but this is a relatively small piece that's duplicated everywhere, okay, in order to minimize this bandwidth cost. But then each worker needs to know, so it's doing some specific work in there, okay? And once they have this work, this is summarized to a challenge. This challenge is less than 10 kilobytes, so this is nothing, okay? This challenge is broadcast to the other servers, but you see it's very, very, very small piece of data that needs to be broadcast, and this is the first interaction. Once this is broadcast to all the servers, they build the actual proof with this. And this proof, it's around 350K, is sent to a single server that actually do the aggregation. In ZisK, doing aggregations is very, 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 very cheap. We are talking that with a GPU, it can take about 85 milliseconds doing an aggregation. You can do many in parallel. So maybe running, if you have to aggregate 2,000 subproofs in there, this is something that may take about a couple of seconds at most in a single GPU. Okay? So this aggregation process is important to understand that can be done really fast. Okay? And this server just do all the aggregation. This aggregation can also be, so we are doing, it's a single server that's doing everything, but this aggregation can also be segmented in parts. So maybe there is one server that's aggregating the first 1,000, the second server that's aggregating the second 1,000, and then you aggregate both of them. And you can choose any structure that you want at the server. Okay? And then with that, you have a proof. But important to see that the bandwidth, it's really, really low. Okay? And generating a proof in the state of, so if you have servers around the globe, the penalty that you get is just a couple of back and forth. I mean, the speed of light, you can see the delay of latency, which is really low. Okay? So how can this be ported in a decentralized protocol? Well, of course, so we are trying to minimize the hardware that each peer we want to have. Okay? And minimizing this hardware is one of the goals of the protocols of each protocol. Okay? So here the proposal here is to have one GPU per cluster. I think this is the. I mean, it's not a single CPU. It's not a Raspberry Pi with some chains, one clumps, but a single cluster, but a single GPU is quite, I would say, is quite affordable. And at the end, if you want to decentralize the proof, so the proof generation, a single GPU probably is a good unit for a server on this. Okay. So, and how you decentralize that? Well, if you substitute this kind of coordinator, I mean, just this server that just taking these challenges, taking these proofs and sending it to the provers to do it. If you substitute that with a consensus algorithm, actually, this is the bandwidth. I mean, you are getting the bandwidth to this blockchain, and this bandwidth is so small that technically this is possible. Okay. I'm going to give you here a couple of ideas of how this proof generation in a decentralized environment. So imagine that, so the example is imagine that you are building Ethereum blocks and you want Ethereum to build a proof for each block, okay? And you want to be part of the protocol itself, okay? So you want to incentivize, you want to put some incentivized mechanism so that this proof is generated as it goes. Okay? This would help, for example, a lot for like clients or even for the same protocol itself, or for validators, etc., etc. Okay? So the simplest one is, okay, this is a little bit funny is like, okay, whoever generates the proof, I just paid. I mean, this is a very simple, very logical, but again, this has the problem that maybe generating, this is limited by the how many people, I mean, how many nodes in the network can generate that big, those big proof. Okay? The simple protocol, simple incentivization protocol, this works. Okay, so probably somebody, I mean, if you pay enough, somebody is gonna build it. But again, this is limited, and there is a problem here that it's a problem of the second, so you don't have incentives for the backup. So the biggest one probably is going to generate all the proofs for the network, and this maybe they will be very well rewarded. But if this stops, who has the incentive to keep a server alive there just in case it fails? And then you will get a minimal thing. Okay, so this is one of the challenges that happens. So it's better to have a way where not a single server is generating the full proof, but this proof is distributed among different places. So here is another idea of how this could work. So the idea is, would be in this case a 3 steps thing. The idea is, okay, well, you split the work say in 32 workers, for example, so you select them randomly, the same way that you are selecting the blog proposer somehow there. Each one has some responsibility to build that proof. Maybe you want to do some redundancy in a place, because some of them maybe they're not building that, so and you want to build the full proof, so maybe you are selecting 2, 3, 4 that's building exactly the same thing, okay? Here you need to incentive. Proposal here is you need to incentive them to do that. So you probably, the people that has to build the proof, will have to pay them. For validators to include these challenges, probably will have to pay them, okay? Same happen in the second stage. In the second stage, okay, so each of these validators, they generate the final proof. You pay them, validators, you pay validators to include this proof, so you put incentive to generate the proof, you put incentive to validators to include the proofs in the chain. And then you have a third step, which, okay, everybody can just generate the final proof, okay, just taking all the proofs that's generated in there. So you pay, so you pay for generating, so you pay for generating this proof and publishing online. You pay validators for publishing that. But here the interesting part is that you can also pay for, not for generating the proof, but if you generated a sub-proof before that's used by the others, you may also get an incentive to get paid. Okay, so the idea is that you have an incentive for the others to use your proof, and the others to use other people's proof. And just about a matter of generating incentives, okay? But the idea here is that this proof should be generated in a distributed manner, in a decentralized way. This is just an example of how the things could do. Of course, here there is a lot of incentive mechanisms here, but I wanted to put it on the table because generating a proof is something that is perfectly possible to do it in a decentralized way. And I think that's important that, Ethereum as a protocol is thinking in this decentralizing the work. Okay. Here there is other topics. Other important things. Just reducing MEVs and on all this but this is, if you want to have a universal protocol, a protocol that's neutral, that can be used by everybody, and that there is nobody that has like an extra control on the protocol. I think this is a fundamental piece in Ethereum, and there is tooling around that, and I think that this should be one of the priorities on the Ethereum protocol. Okay. You can do, of course, well, you can do a lot of innovations on these protocols. This needs a lot of research work. But these are some of the advantages, some of the advantages of this protocol. Especially, I want to remark this liveness. I mean, this is an liveness and censorship resistant. Okay, so that's very much my presentation. I mean, I don't know if there is some questions here.
For the settlement clear, like the proof verifiers of these proofs, we need just some updated protocols for these verifications, or is it the existing infrastructure here on that? Just over. Because I just assume it's much different if I present this stars and stuff like that.
Yeah, the question is about verification. I mean, the cost of this verification, if they need something special. Verification in zero knowledge is very, very simple and very straightforward. I mean, verifying a Stark, we are talking about, I don't know, maybe like 20, 30 milliseconds in a CPU. No, you don't even need a GPU. So the verification cost for a network like that, or even in a protocol that you need to verify partial things, it's quite simple. And here, something that to notice, I mean, for example, in the first stage, you could generate a proof that's incorrect, okay? So you generate a stage. Well, at the end, when you are publishing the challenge of all of them, that's why it's important. That's why it's important the redundancy, because someone can not generate or generate something wrong. But the idea is you can put incentives to detect what's the wrong. Maybe somebody will have to select the one, but then you can either penalty the one or just don't pay him, the guy that's using. And in the end, because the proof is not going to be used by the rest of that because it's incorrect, then there are some incentive. But it's relatively easy to do this partial verification. One thing that I didn't mention is that the first two stages are just for generating proof in an optimal way. You can reduce the two first stages, maybe in a single one, just generating the full proof directly and then aggregating normal proofs. Okay, and then in this case, it's as easy as generating the proof.
Feature easy initiative, basically there would be like centralized these provers who else would be communicating with to have this generation.
Yeah, this is not related. Nothing. I mean, this is not related to easy, but easy is an example of how protocols can go to a more centralized generation part. I mean, in easy, provers will generate that. In easy, we don't define who will submit this prover. I mean, it's a smart contract that's accepting a proof at a higher level. Okay, I'm talking more at the consensus. So at the consensus layer, we don't want that there is a single entity, a single role that accumulates a lot of power just because he has like a big cluster with a lot of GPUs and is the only one that's able to build certain kind of proofs. So the full idea is how can we do in order to build that proof in a decentralized manner. Okay, this has the advantages that first it can scale more because I mean if there is more demand, the idea is that you can always put more hardware and there is more incentive to put there. You have the incentive of the liveness. So the idea is that, okay, if a server stops, a protocol continue working. And you have also the advantage of censorship resistant. I mean, it's like you can, I mean, if people is just building proofs and there's many people building proof. If you are not building proof, that's more problematic. I mean, it's not a single one that can take the decision of just not building proof, okay? So my idea of this talk is that at least at a proof building level, this is perfectly possible. I mean, there is no I mean, there is no important reasons for these proofs to be generated in a centralized manner. Of course, at the beginning it's easy. When you are developing, that's what you do. But I mean, this should not be an excuse. So that the proofs are big, that the proofs requires a lot of hardware, it should not be an excuse for centralizing the protocol. I mean, the excuse is more that the centralization is hard for you need to put all the incentives mechanism, and I mean, you know, it's harder for that, but not because the proof generation is you need to do it in a big cluster. You can build it split in a spread-wise.
Proof generation is a distributed service.
Exactly. Yeah, there is this proving networks. They are a little bit in that sense. The problem is that, this is in my opinion, you cannot. So if you're having a consensus, I mean, a consensus protocol, you can. I think it's hard to delegate one consensus protocol in another consensus protocol. So I think it's much easier to put a single consensus protocol. If not, you have dependencies on one each other, and I think that the system may become very, very, very complex. So I think it's easier to do a single consensus protocol that integrates in the same consensus protocol the proof generation as implicit part of the, as part of the consensus. Just as a side note, but this is just ideas for thought. Aggregating this proof, I mean, when you are taking various proof and you want to aggregate this proof, so for in Ethereum, you have to aggregate the BLS, okay? When you want to convert this BLS to quantum resistant, there is no very good protocol to aggregate signatures with quantum resistant idea, okay? So maybe it's a good opportunity because the best way we know to aggregate signatures in quantum resistant is using snarks, okay? So if you end up generating a proof for a snarks and a proof for a BLS and aggregating them, maybe you can aggregate the full proof. So you can use this aggregation that you need to do anyway for the other things to think in I mean, not only aggregating the BLS, but aggregating the different pieces of the proof in order to build a block. Again, I mean, a lot of things. I mean, I'm not planning here to solve Ethereum at all, okay? But my message here is very clear. I mean, it's generating of the proof can be done in a decentralized manner. This is the message that I think is very clear that I want to transfer to the people that are responsible for building protocols, because it's something that it's really important. I heard too many times that, okay, it's an excuse. So this becomes the generating this proof is an excuse for generating these. It's an excuse for centralizing.